Hello, my name is Tyra, and I will be introducing a new methodology for selective structure-based small molecule drug discovery. The global pharmaceutical industry is worth $1.25 trillion. Specifically in the US, $474 million are devoted to preclinical small molecule discovery for therapeutics. For diseases with a known target protein, the current workflow of discovering drugs involves hit identification, lead development, and lead optimization. Structure-based drug discovery is a class of techniques with varying costs and accuracies that involve using the three-dimensional structure of proteins to target diseases. The computational docking method is the cheapest, least accurate method, and it mimics the physical process of docking. Docking is the process of a ligand fitting into a binding site in a protein. In computational docking, a ligand is docked into a binding site of a protein and a score is printed out. A lower docking score is associated with a higher binding affinity, meaning that the ligand is most likely to bind to the protein. One of the challenges with protein inhibition is the possibility of the inhibitor binding off-target proteins. Off-target effects are the result of a small molecule binding to an unintended target and sometimes cause deleterious effects in certain medications. Off-target effects could potentially contribute to drug failure in clinical trials. In this study, we are interested in discovering selective inhibitors of TYK2, a kinase with implications for treating type 1 diabetes. TYK2 is prone to off-target binding effects. The function of TYK2 is to regulate apoptotic and pro-inflammatory pathways in pancreatic beta cells. And a previous study identified TYK2 inhibition to be linked to a lower risk of contracting type 1 diabetes. So for the purpose of this research project, our group will look to inhibit this protein while avoiding others. This is what will make the drug selective in that the only protein related to the disease will be targeted. The challenge will be finding a protein with the lowest docking score and the most selective. The plan for this research is to select the target protein, TYK2, dock 10,000 ligands against this protein and off-target proteins, and train a surrogate model with the docking data and collect top predicted molecules from a virtual library. We will be using Autodoc Mina to dock as well as the following software and data. Here we have the TYK2 and 4 off-target proteins. Here we have the protein selectivity screen for the top 10 scores of the TYK2 protein. The panel highlighted in red represents the most selective ligand for the selectivity screen. This ligand is chemically represented below. The poses show that the ligand docks inside the binding site for the TYK2 protein and outside the binding site for the off-target proteins. To supplement this study, our lab will look into the predicted results of a larger virtual library of molecules using the data collected from this study to train a surrogate model. Thank you for attending this talk. For more information, please visit my poster session to learn more about the research.